Based on the environment that they are flying and the type of the mission that they are doing, they can have a they can do a variety of missions. So for example, those can be used in the space, for the planetary exploration. There are plenty of birds and insects that we can get inspiration from them to design some flapping wing drones. So this is one example of the flapping wing that you can see. This has been inspired by some type of birds. The flapping wings, they are totally different with the fixed wing. The type of the actuator that you're using is totally different with the fixed wing drone. I also have an example of the fixed wing drone that has been designed and manufactured by high school students. As you can see here, this is called a fixed wing micro-aerial vehicle. It's composed of a wing, a vertical tail, and it has a propulsion system, which is an electrical motor and a propeller. So drones, they have a different sizes. I mean, we have the big drones, which is called UAV, to insect-sized drones. So drones that they are usually inspired by the insects, and they can flap with a very high flapping frequency. So as I said, depend on the type of the missions that we wanted to do, we can have a different configuration. So for example, you have fixed wing, you have flapping wing, you have the multi-rotor drones that we are going to show you today some example of this. So this is one of the prototypes that we have made, which can carry cargo, and it can do a replacement for the battery. So here, this is a quadcopter because it has 4 motors. So these multi-rotors, they can change the flight modes from, hovering to the forward flight. So these are so interesting concept for doing, different types of the mission that sometimes we need the speed, sometimes we need to do the hovering. So they can provide this type of flights that we need for our mission. So here, as I said, the main research that we are doing, and the next students that is going to talk about that, is getting inspiration from the nature in order to have some optimized concept for this autonomous system. So as we discussed here, nature has developed different types of behavior, materials, and through the millions of years, and it gives us some good idea that how we can come with some optimized solution for this type of robotic system. So the next speaker will be Ms. Michelle Sherman, and she will talk about the dandelion-inspired robotic system for the Mars exploration.
Student at New Mexico Tech studying mathematics and electrical engineering. And for the past couple of months, I've been working with Dr. Mustafa on a project dealing with dandelion micro rovers for Martian exploration. And so the primary motivation behind this research came from looking at the challenges that the land rovers that NASA has sent to Mars have encountered. One of those problems deals with rough terrain and sharp rocks on the Martian surface. The Curiosity rover, for example, has sustained significant wheel damage from encountering regions with sharp rocks. Currently NASA is developing different autonomous systems for Martian exploration. And one of those concepts is designing a spherical robot that can actually roll on the Martian surface. And it can collect water resources, it can do different temperature, pressure, and different measurement samples as it rolls along the surface. And it uses the wind patterns to be able to roll over the Martian surface. And so I started looking at different bio-inspired concepts that would be able to add another dimension of transportation on the red planet. And so I started looking at aerial systems, and I looked at bio-inspired concepts that use aerial flight as their transportation. And one of those nature concepts is the dandelion flower. So their seeds, as the wind passes through a dandelion flower, their seeds into different locations and different environments. And so one of the things that NASA is looking into currently is the NASA Odyssey orbiter recorded 1,000 potential cave entrances, shown in Figure 3. And so they want to send a rover into these caves to be able to explore different environmental characteristics. And they want information on these caves so that they would have the potential for being possible human occupation centers. And they want to send these robots to record different characteristics to get a better understanding of their structure. So I thought, what if we could harness this dandelion concept and send thousands of these micro rovers into those caves? Look at Figure 5. I thought, what if we had a spherical robot that houses dandelion seeds within its internal shell, and it would be able to roll on the Martian surface or even crawl just like a spider. That's why we see legs there in the bottom figure. It would be able to roll and crawl along the Martian surface, and once it enters those cave entrances, it disperses these dandelion seeds into those caves. Those dandelion microrovers would be able to record a bunch of different measurements, anywhere from temperature, radiation levels. They would be looking for subterranean aquifers and possible water resources. They would even look for present or even past life, alien life as well. And that would give scientists and engineers a better understanding of their cave structure. So that way, it would allow them to plan for an optimal path for their more expensive robots, their more expensive rovers, to be able to go into those caves and get a better understanding. And that way, scientists and engineers would be able to use these caves and lava tubes for potential human habitation. And so that's the research that I've been working on with Dr. Mustafa, and I'm very excited for this project. And I hope you have a great rest of your day in this Science Expo.
Hi, so my name is Mariah Gamble. I am a mechanical engineer at New Mexico Tech. I will be talking about, so I'll go ahead and share my screen. Okay. So Titan is a really cool place. It's one of Saturn's moons, but it's also one of the most that we found in our solar system. And so because Titan is so far away from the sun, around 886 million miles, not the sunlight reaches it. Titan also has a really thick atmosphere. Spheres just as that are on Titan. So on Earth we have oxygen and nitrogen and other gases. Titan also has a lot of nitrogen, but much, much more than on Earth. This thick Titan really orange, hazy look, where it's hard to see through to the surface. However, NASA was able to get a better look at Titan's surface using infrared sensors. And so this year also allows for even less sunlight to reach the surface of Titan. And because of this, Titan is really, really cold at around negative 292 degrees Fahrenheit. And at this temperature, methane, which methane is just a fancy word for natural gas, which we use here on Earth in our homes, in gas stoves and heaters. But these really cold years, methane is liquid. And so Titan has an abundance of liquid methane, which makes up lakes and rivers similar to Earth. And so this image shows the North Pole of Titan, which is lakes. It's also been proof that it rains liquid methane on Titan. And so these similarities to Earth make Titan a really interesting place to explore. And so remember when I mentioned that Titan's atmosphere is really thick? So this characteristic, along with lowered gravity on Titan, makes flying really easy. And so it's been said that it usually fly on Titan just by strapping on some wings. And because of this, it's a really good idea to explore drones. And as a matter of fact, NASA is sending a rotorcraft drone to Titan in 2026 called the Dragon. And so this drone will look for information about the origins of Titan and for signs of life there. However, Titan's similarities to Earth make it a great place for even further exploration. And so my research involved designing a drone for exploring Titan that draws energy from its natural features. So here on Earth, albatrosses can fly for years without landing, and they do this by gaining energy from the wind on the ocean. A similar idea could be used on Titan to harvest energy while flying. Titan's liquid methane lakes could also be used as a fuel source for propelling the drone forward, as liquid methane is used here on Earth with liquid oxygen as rocket fuel. And would be able to save energy by landing on Titan's liquid methane lakes in order to fuel its systems. And so using these native Titan, the drone will be able to fly longer and explore more of this moon, which would give us more information about our universe. So that's the research that I'm doing here. Also really excited about it. Yeah, thank you.
Mm-hmm. My name is Megan Richardson. I am an undergrad here at New Mexico Tech University in mechanical engineering, and I'm currently working on looking at manta ray and mimicking them into drones. Manta rays are especially interesting because they have a relatively low frequency, flapping frequency, only half a hertz, comparably to most other animals that have wings that flap. They can also, for a brief amount of time, hop out of water. I'm learning how I'm mimicking this manta ray for water exploration and potential space exploration. In order to understand how manta rays move through air and water, we use different softwares to look at the drag and the lift, as well as how it flows through the air. At the end of this video, you can see a development that another company has made of a manta ray drone. Next, we will hear from Brendan about his research with amphibious drones.
Hello, everyone. My name is Brendan, and I'm an undergraduate student in the Mechanical Engineering Department at New Mexico Tech. And over the past year, I've been working with Dr. Hassan Alian to develop an amphibious drone system with a wide range of applications. Let me see if I can share my screen here. So Bioinspiration is a very useful tool to consider when designing cool new technologies for the future. This is the process of looking at things we see in nature and utilizing them to improve our designs or concepts to help further design efficiency. Nature's had millions of years to tweak designs and implement efficient changes, and from this we've been able to take inspiration from multiple animals and plants in the design of an amphibious drone concept, which hopefully you can see in the bottom left. There are several species of amazing oceanic birds that have influenced the design and application of this drone, one of which is the albatross. This bird has incredible flight capabilities and can fly 10,000 miles without even flapping its wings. And that's far enough to fly across the United States 3 times and some. They do this by using special wind patterns that form over the oceans and carry them the entire distance while they use almost none of their own energy. One of the greatest problems with small and medium-scale drones is their flight endurance. By taking inspiration from these albatross, we can create a drone that could fly much longer than any typical design, which would allow for highly extended mission duration. In our design, this aerial drone would carry an aquatic member that could be dropped into the water and allowed to collect data pertaining to its mission. By implementing other energy harvesting techniques, such as solar collection and wave motion, the aerial drone could recharge while the aquatic member carries out its directive. In conjunction with this, inspiration can be taken from water lilies, more specifically the giant Amazonian water lily. This water lily floats on the surface and harvests energy from the sunlight it receives. It also provides for small animals such as frogs and birds where they can rest. And this concept can be applied to a floating drone hub out in the middle of the ocean or even in lakes. This drone hub could utilize floating solar technology to collect energy as a solar farm while also providing a landing platform for the amphibious drones where they could return for a new mission and give the data out to different places. So this creates a multifunctional system that can make use of open sections of water for energy collection and provide shelter to the drones during adverse weather, which would be encountered during operational times. These two concepts highlight some of the amazing ideas that we can implement just by looking out the window. And that's my interest here at New Mexico Tech. Thank you.
Hey everyone, my name is Stephen Luco and I am a grad student in mechanical engineering, and though I did my undergrad in electrical engineering. Today I'd like to talk to you about this drone that I put together. It was started about a month ago. It's for a project for drones, or for Mars research. where the idea is that we have a large fixed-wing drone, like an airplane, that has two of these guys on it that can drop off and disattach or unattach and fly around, do some surveillance, and then reattach back to the fixed-wing drone. So I guess I'd love to fly this in here for you, but I'm pretty sure Dr. Mustafa wouldn't like that in his office. So if we could roll the video here, see it flying outside. If you look really closely, it actually crashes here in the beginning. Let's see. Oh, it looks like the video may have started midway through. That's all right. So you see it flies pretty well. There we go. See, I'm not sure how well synced up this is, but the reason it crashed was because of a small software mistake that I made, where it decided to just disarm the drone while it was in the air. And so although the rest of the image processing and flight path stuff was working fine, the one small mistake caused it to just fall. This is very much something that's in development. Again, I started very recently, and so pretty much every day I'm adding new features, new code, even new hardware. Like as I discover I need a new sensor, then I'm able to add that on, program something to interpret it, and then have the drone be able to use it properly. Another thing you may be able to see is that the camera in the center is actually a thermal camera, but it's wiggling around a lot. And that was another mistake that I made. This was the first flight, so it was really good figuring out where these issues were. But it's actually supposed to stabilize, and I do have that demo working today. So in fact, I will plug in my drone here, and I'll be able to show you some functions of it. First step is safety glasses, of course. And if I could get some help to move the camera to show the drone, I'll plug it in here. Make some beep. All right. Now, let's see here. This will probably take about 20 or 30 seconds, so I'll just talk about the hardware while it decides to turn on. We have a Raspberry Pi here, which some of you may have used before. It's similar to an Arduino in a sense where you can program it and have it run code, but it's actually like a full-fledged computer. So I could attach a monitor to the HDMI port on the side here and be able to actually see the screen. I have that as like the main brain that is talking to the thermal camera here. And so that is running a real-time image processing algorithm to detect a electromagnet, which is a heat source circular. The very first version of this drone was only able to see like high contrast, but now we actually have it. Let's see. We'll show the stabilization. See if that's showing up on camera. Sorry about the keyboard. Camera's a little interesting. Here, we see it stabilize a little bit, and then the other function I have, switching it into auto mode, if we just put the camera down a little bit, is that I can hold this electromagnet above it. Can you pull the camera a little bit more? You can see the magnet. There we go. And we can see that it is tracking it pretty well. One small issue that I'm having is it is seeing the light up above here. It's another heat source. It's interpreting that as the target. Again, something else we'll have to figure out at some point. But overall, it works pretty well. Very happy with it. I was involved with designing the software, the hardware, the electronics, pretty much every step of the process. Set up the wiring, did all the programming, all that stuff. So again, it's like a very, very like fast development. But I want to show it to you guys to show that like engineering isn't always like this clean process where you can like design something and have it work the first time. It's very often that you'll build something, design it, and maybe it doesn't work the first time, but maybe you can learn something really good from that, and then use that information to put the camera back here. Use that information to develop further in the future. So I think that is pretty much all I have to say about that. Do we have any questions or?
So, Steven, can you talk about the mission of this drone?
Oh, yeah, of course, yeah. So I was kind of glazing over. So this is designed for Mars research, and of course, flying it on Earth doesn't seem to make sense if we're going to be flying it on Mars. The atmosphere is different, the gravity is different, but I don't have a way of putting this drone on Mars yet, so we got to make sure that it actually works here first before we can start designing it for these other environments. So I guess the part that isn't complete on this drone here, and I'll just pull it up here, is the top section doesn't have any way to attach to the larger fixed wing. That's because I'm kind of building everything on this small quad rotor first, and then I'll design the other parts that it attaches to later. The reason we went with a thermal camera on this instead of like a regular camera like you can see me on is because we're hoping that it can see like high contrast of the ship that it's supposed to dock into against the background of Mars, since it is very, very cold there. And maybe like dust would get in the way of like a regular vision camera. The reason I installed the gimbal on it is because the field of view of this camera is very small. Like it can see maybe like less than, I don't know, a square inch of my palm sitting up here. So it really doesn't see very far. And so by allowing it to move, I'm able to artificially increase that to my needs. And also this top plate mostly just acts as like a protective cage to make sure if it does do something where it flips around, it doesn't just destroy the thermal camera every time I go flying it. So I guess another thing to mention is the legs that broke during the flight test. I'm not sure if you saw it, but they were actually designed to break because the connection points here are very, how do you see it? They're pretty weak, and so the idea is that they'll break and then absorb the impact and not have the electronics get destroyed.
So I can speak a little bit about flights on Mars. So one of the challenges of the flying on Mars is that in Mars the density is so low, so it's so important that how we can have an optimized flight on a Martian environment. So this is one of the main challenges once we do the comparison between the Martian environment and the Earth, because we are dealing with a different gravity. The gravity in Mars is about 30% of the gravity of Earth, and also there is a challenge with the atmospheric conditions. So we are looking at some novel concepts that they can tolerate for a long time in the Martian environment. So here, if anybody has any questions here, you can put in the chat, and we'll be happy to answer any question regarding the research that you are doing at the Mechanical Engineering Department at New Mexico Tech. There is a question here is asking, do all drones have 4 helicopter blades? So no, I mean, drones have a different configuration. So they can have 1 up to 12 blades. So the one is considered the monocopter. The fixed wing drone, usually they just have 1 propeller here as a propulsion system. But we also have some monocopters that they just have single rotor with a wing that they have been inspired from a leaf of the trees, which they pass a helix shape during the motion. So we can have 2 motors, which is called twin-copter. We can have 3 called tricopter. So this type of concept with the 4 rotors called quadcopters, or quad rotors. So we can also have it to 5, it's called the penta. We have 6 called hexa. So we can have up to 12 motors on this type of rotary wings. So as I said, I mean, these are the drones that the propulsion system is coming because of the motor and propeller. We also have the flapping wings, which they are usually flat, and they have actuation mechanism like the birds, and they can do different types of flapping motion. So here I'm going to show you a tour of my office to show you that what process we are doing in order to design the drone. So as you can see here, there are lots of engineering behind the designing a drone. So this is a whole process that we usually follow up in order to have to design an optimized drone for a variety of applications. So here we would be happy, me and my students, to answer any question that you have. So if you send us question, we can answer your question here regarding the drones, and for Bioinspiration, Biomimetics, that whole inspiration from the nature would help us to design some optimized drones for a variety of application or missions. So here we also have, as you can see here, there are 2 different types of the fixed wing drones that they can be used for different applications. So drones can apply, as Brendan mentioned, can apply in the marine environment and can fly also under the water. So we can have different types of amphibious drones that they can apply for marine environment. So thank you so much for watching us here. We had some issues with our camera. I'm sorry for the low quality of the camera. So I hope all of you guys, you will have a good weekend and you have enjoyed this talk.